All right. Good morning, everyone, or good afternoon, good evening, whenever it is that you're watching this video. I apologize if you were trying to get on live this morning. I apologize for the late start. I had some technical difficulties here at home. You guys know what that's like, but we're here now, so let's go ahead and get started. So, the assignment today is already posted up on Canvas. Obviously, you know that because you're watching this video, which is part of the assignment. All right. The assignment, as you can see in the description, you're going to do it online today. And then when we come back to school, hopefully next week, fingers crossed, hopefully next week we'll be back at school. Um, then we'll just transfer it into your notebook. We'll put it on paper. But I want you to at least take some time to practice what it is that we're doing so that we don't forget, we can remember what it is that we learned last week. So, the assignment, let me go ahead and share my screen here. Okay, so your assignment is obviously you scroll down to the bottom, you found the assignment because that's where this video is. It's the valence and oxidation numbers. We're just going to be practicing uh, valence and oxidation numbers, reviewing from last week. So this is the assignment down here. It should open up in a new window or a new tab. So you want that to open up. If you haven't used your Google account yet with Canvas, then you need to do that. You need to authorize it. It's not going to work. Hang on a second. Let's do this. This is what you get when it's alive. Well, I guess it's not live when you're watching it now, but okay, so it should look something like this. So I'm going to go ahead and zoom in on this so we can see it better. But it should look something like this. You should be able to, from your Canvas page, you should be able to open up that assignment. It's a Google Slides. Everything that you need to do is outlined in red. As you can see here, everything is outlined in red. As you scroll down, all of these boxes that are outlined in red, that is what you need to do for this assignment. I have a paper copy here that I'm going to go through at least a couple of questions together. And then if you have any questions, I will be available all day during normal school time. Also this evening, if you have any questions, feel free to reach out, send me an email, shoot me a text if you have any questions or if you need any help. So let's go ahead and let me share this other one. Where did it go? Oh no. Oh no. Let me try this. Hang on. No, why is it not working? There it is. Got it. All right, so I have, like I said, I have a paper copy. This is the same one that you will be doing, that you will be working on when we come back to school next week. It's exactly the same as what you're going to be doing online, just a paper copy. So let's go ahead and go through this. So these first boxes up here, I just want you to write in the valence number. So if you have your notes, you can look that up. Here's how we remember. So remember, it goes, the pattern is we start with 1, and then we go 2, and then of course we're going to skip over here and we go 3, 4, 5, 6, 7, and 8. Remember, our valence number is the number of electrons in the outermost energy level of our atom. And here's the pattern. This group is always going to be 1, 2, 3, 4, 5, 6, 7, and 8. Now, if you have your notes, you should have already written that down on your periodic table. If not, well, now you do have it written down. If you do have it, well, now you got it twice. Twice is always better than one. As far as oxidation number, remember oxidation number, it tells us how many electrons the atom is going to lose or gain in order to have a full valence energy level, a full valence shell. So this first group here, remember it's easier for this first group to lose that one valence electron than it is to gain 7 more. So this one is going to lose 1 electron. And when you lose 1 electron, right, remember electrons are negative. So when you lose an electron, the atom is going to become more positive. So the oxidation number here is going to be plus positive because it's losing negativity. When you lose negativity, you become more positive. So it's plus, how many electrons is it losing? Well, it's losing all of its valence electrons, so plus 1. This group over here, exactly the same. It's easier to lose 2 than it is to gain 5. So this is going to be positive 2. If we jump over here to this group over here, this group here already has 8 valence electrons. It already has a full energy level. So its oxidation number is going to be 0. It's not going to lose or gain any. Group 17 right here, that starts with fluorine. It has 7 valence electrons. It only wants 1 more. That's a lot easier to gain 1 than it is to lose 7. And so this is going to be negative because it's gaining a positive, or sorry, it's gaining a negative electron. So it's going to be negative 1. Negative 1 is going to be the oxidation number for all of the elements in this group here. If we go to the next one, this one has 6 valence electrons. It's easier to gain 2 electrons than it is to lose 6. And so this one is going to be negative 2. Now, we went over this all last week. This should be a review. I'm going to let you fill in the rest of those. So skipping down to the quick practice down at the bottom. If you haven't filled in your valence numbers and oxidation numbers yet, go ahead and pause the video, go do that, and then come back. So if we start here, how many valence electrons does each of these have? So potassium is K. That's going to be in group 1. So that's going to have 1 electron. Silicon here for B. Silicon is Si, which is over here in group 14. Group 14, this is going to have 4 valence electrons. Iodine over here in group 17 is going to have 7 valence electrons. Nitrogen, being in group 15, is going to have 5 valence electrons. All right, so that's question 1. Question 2 says to draw the Lewis dot structure for each. So a quick review on how to draw Lewis dot structures. The first thing you've got to do is you've got to know how many valence electrons this atom has. So I'm just going to write that number here down underneath. There isn't a spot for it on your assignment, so don't worry about having to write that down. I'm just going to write it down so that we can remember. So carbon has 4, barium has 2, hydrogen has 1, and argon has 8. So these are the number of valence electrons. These are the number of dots that we need in our Lewis dot structure. So carbon, here's how we do this. We're going to do a C, and then we're going to put 4 dots around it, just like that. Remember, we don't double up. We don't pair up our electrons until we get more than 4, until we get to 5. So let's go over here. I'm just going to do hydrogen, and then I'll let you do the other 2 on your own. Hydrogen has 1 dot, so that one's going to be easy. It's just going to be an H, and then 1 dot. Okay, now for your assignment, let me show you this. Oh, that's not what I wanted. So for your assignment, I made these little dots on the side of the slide here for you to drag these dots over in order to make your dot diagram. So for carbon, I would put a dot there, and then I'd come over here and grab another dot. And then I need 4, so one more. And then this one here. Now it's not going to be perfect like when you draw them, but this is close enough. So I've got my 4 dots, put a C in the middle, and then there's my Lewis dot diagram. So again, it's not going to be perfect like when we did it on paper, but this is close enough for what we're doing. So I'm just looking to see, now it's horrible. I'm just looking to see how many dots you have around it. So as close as you can get to that. Again, it's not going to be perfect. It's better on paper, but we'll do the best that we can with what we've got. So that's how you would do that part of the assignment for today. All right, if we keep on going with the next question, question number 3, it says, what's the oxidation number of these different elements? Is it? Hang on. Why is it not working? Come on, computer. There we go. For some reason, my camera stopped working. And now it's not letting me share it. Shoot. The joys of technology. Thank you for sticking around if you're actually been watching the video this long. Come on. Well, okay, well, that's not working. So I'll just show you in the Google slide then. Okay, so if we're down here on question number 3, what's the oxidation number of rubidium? Rb, so we come up here and we find that rubidium is right here. It's in group number 1. And as we already learned, group number 1 has 1 valence electron. So that means our oxidation number is going to be positive 1. Don't just write 1. You need to have the positive. Okay, if we look over here at part D, chlorine. Okay, chlorine, if we go up and we look for it, chlorine is over here in group 17. Okay, and group 17 has an oxidation number of -1. Again, don't just write 1. It needs to be -1. Question number 4 says to underline the elements in questions 1, 2, and 3 that will gain electrons. So if we look at questions 1, 2, and 3, we need to underline them. So I'm going to insert a line. We're going to underline the elements that will gain electrons. So gain electrons, which means they have a negative oxidation number. So that's going to be chlorine. And just so you guys can see it, I'm going to make this a little bit bigger of a line here. If you don't want to do that, that's fine. I'll figure it out. But so I've got chlorine. So chlorine is going to gain electrons. Oxygen is also going to gain electrons. So I'm just going to copy and paste that line and put it over here under oxygen. Rubidium will not gain electrons. Boron is not going to gain electrons. Up here in question number 2, carbon could, because it's got 4, could gain electrons. So I'm going to underline that one. Barium will not, hydrogen will not, argon will not. If we go up to question number 1, potassium will not gain electrons. Silicon is similar to carbon. So I'm going to come put that line up here under silicon because of its 4 valence electrons. Silicon could gain electrons. Iodine, being in group 17, will gain electrons. And nitrogen, being in group 15, will also gain electrons. So remember, I just Come up here to the line. I inserted a line, and then I just copied and pasted it for all the other different lines that I have that I need. All right, so that's question 4. Question 5 says circle the elements that will lose electrons. So I'm going to come in here and pick a circle. So it's basically all of the other ones with one exception. Circle the elements in questions 1, 2, and 3 that will lose electrons. So that's going to be rubidium. I'm going to circle that one, and make sure when you circle it, you have, let's see, I don't want to fill it. So how do I get rid of that? Oh, transparent down here. So make sure if you do that, and then again, I'm going to make it color so you can see it a little bit better. Make this a little thicker. There we go. So there's my circle around rubidium. The ones that will lose electrons, again, that's going to be boron, and then barium, hydrogen up here. Argon will not gain electrons. It will not lose electrons either because it already has its 8 valence electrons, and it's good with 8. So I've got the ones underlined that will lose electrons. Underlined that will gain electrons, circled that will lose electrons. There are 2 that you should circle and underline. There are 2 that you should circle and underline. I am not going to tell you what those are. I'm going to let you figure out what those are. All right, and then down here for number 6, it says, what would you predict would be the valence number and oxidation number of tin? Here's tin right here, group 14, so you know how to answer that question. So how many valence electrons and its oxidation number. All right, so that's the assignment for today. Sorry this video went so long. Sorry we had some technical difficulties, but if you have any questions, like I said, I'll be available all day. Feel free to reach out, send me an email, shoot me a text. Otherwise, I will see you guys later. Have a great day. Bye.